Black Lives Count Toward Accountability and Efforts to Diversify Computing. And give you an outline here. I tried to outline this in a way that sort of resembles a scientific talk with background and motivation, data analysis, solutions. So in some sense, it has a traditional structure for a technical talk, but in other ways, it's probably radically different from most of the things that we tend to talk about. So a little bit of background. This talk actually started as 4 slides at the end of my job talk in January of 2021 for this job. So you might ask yourself, why was I talking about diversity and inclusion when I was interviewing for a job to lead a group on computer languages and system software? So that's where some background helps. So I have a long background with Berkeley Lab, even though I just started working here last year in May. I first gave a talk at the lab back around 2005, and then took an interest in joining the lab a few years later, and actually interviewed twice for jobs here, once in 2012 and then again in 2013, and didn't get the job either of those times. And somewhere along the way after that, I had a couple of conversations with a scientist who used to work here at the lab, who's African American. And I remember asking him if he knew any other African American scientists at Berkeley Lab. And he said only students and postdocs, nobody on the permanent staff. And that surprised me, but I didn't maybe think about it that much more until I heard that he retired. And he was about 50 at the time, roughly. So pretty early for somebody to retire. I was surprised by that. And it suddenly occurred to me that if he had been there long enough to retire, and he'd been there for quite a while, and if he didn't know anybody, there might not be anybody. And so I actually happened at the time to know the chief operating officer for Berkeley Lab. And I reached out to him and I said, hey, I'm not sure you guys have any Black scientists there. And he checked with the HR director, who checked the database and actually confirmed it. Now, staff scientist is kind of a unique title here. There are also a lot of people who are in a role called a computer systems engineer. In fact, in my group, we have a lot more computer systems engineers than we have staff scientists, but it's basically the PI role. And it's in many ways analogous to a professor in a university setting. And so, I had this kind of takes me back to this dialogue I had going in my head when I was in my 20s, when I would walk into a room, oftentimes maybe a classroom when I was in grad school at Stanford, and I'd look around and I'd be the only Black student in the room. And I'd often think, so that means that if I weren't here, there wouldn't be any African Americans here. And would anybody notice? And for a long time, that was just sort of this rhetorical question in my head that I didn't really think necessarily had an answer. By the time I was in my 30s, I had firmly concluded that the answer was probably no. And so how is it we get to a point that a DOE national laboratory doesn't have a single Black staff scientist and nobody notices? Like the COO has to check with the HR director, who has to check in the database to figure this out. So it brings the question, where is everybody? How do you get to this point? How do you get to zero? So that's why I was talking about this in my job talk. The job talk was Why Fortran Persists, Experiences with Teaching an Underdog Language, New Tricks. And over time, I've expanded this into a whole talk, gave a similar talk at the PASC conference in Switzerland in June. And so that's what you're seeing today. And I've added a few slides since June. So even if you saw that one, there'll be a little bit of new material here. So more by way of motivation, I was really excited in April when the Biden-Harris administration announced a whole of government effort aimed at generating disaggregated statistical estimates to characterize experiences of historically underserved groups using survey data. And they wanted to increase non-federal research and community access to disaggregated data. So what do they mean by that? They're going on about disaggregated data here. So let's talk a little bit about my view on data disaggregation. If you look at the workforce data that Berkeley Lab puts online, we form these groupings where we have women, underrepresented minorities, which includes African Americans as well as Hispanics and Native Americans, other people of color, which includes Asians and Asian Americans as well as Pacific Islanders, and 2 or more races or ethnicity, and then white employees. So I would call this aggregated data, meaning that we've lumped these different groups together into these categories like underrepresented minorities. So one of the reasons you maybe don't notice what's going on when a certain population is now completely absent is because you've lumped that population in with other populations. And so I would say that we need to disaggregate this data to really understand what's happening. I was really excited when I first came to the lab because it was the first place that I heard this acronym IDEA: inclusion, diversity, equity, accountability. But if you think about the word accountability, and one of the root words for that is count, it's a little bit hard to argue that Black lives count if we can't count Black lives, right? So I would say that we really need to look at disaggregating our workforce data so that we can understand what's happening in various places. The good news is that the DOE labs are putting this information, a lot of information like this online, and some of them are disaggregating. So there's this one website, I should have the URL here. Maybe if there's somewhere that we're going to post these slides online afterwards, I'll include the URL so that everybody knows how to get here. But there are 17 DOE labs, 16 of them at least put workforce demographic data online. And just to give you an example of one that disaggregates, Argonne National Lab does actually break their data down by race. So I've been asking for this sort of information since I got to Berkeley Lab and still haven't gotten it. Oftentimes the explanations I hear are, well, if the numbers are too small, then you can identify, a person, you can figure out who is in that percentage, because it's 1 over, the number of employees in that division or something like that. I guess my pushback on that is when you get to the point that the number's 0, then whose privacy are you protecting by not putting this data out there? And so if we're saying that the reasons we don't disaggregate is because the numbers are too small, that's kind of like saying if the problem is too bad, we can't tell you, right? So fortunately, there are a number of labs that are disaggregating by race or ethnicity. I counted 6 by going through this website, 6 out of 16 listed here. So it's a minority. Fortunately, it's not a tiny minority, but I don't know what would make the difference between Berkeley Lab, for example, and one of these labs that does disaggregate. I assume they have the same privacy issues that we have. So let's think about the most common reason that people talk about why we have underrepresentation. People tend to jump right to the pipeline, right? And the issue I have with that is we generally hand wave when it comes to this. And we bring shockingly little rigor and data to bear on this problem, despite the fact that in all of our other work, when we're doing science and when we're doing research software engineering, so much of it is driven by data and driven by analysis. But when we talk about the pipeline, we just kind of throw the problem into the pipeline and say, we can't solve it, or we have to, get more kids in K through 12 to think about science, what have you. So let's actually look at the data on what's in the pipeline. So this came out in January. I guess actually, well, this says awarded in 2019, but this data just came out in January of this year. And if you average across STEM fields, mathematics, statistics, engineering, computer science, and certainly in computing sciences, we're pulling from all these different fields. As was mentioned, my degrees are mechanical engineering, even though I'm in a computer science role here. Let's say roughly 3% of PhDs are African-American in these fields. Okay, so analysis. Pretty simple to think through what would be the probability of reaching 0, right? And obviously this is not hypothetical. I'm saying Berkeley Lab did actually reach 0 at one point. Let's say if we just think about how it can happen just through random sampling. So if there's a 3% chance that someone you hire is African-American based on what's in the pipeline, then there's a 97% chance that they won't be. So you post a job, you hire, and most times, the overwhelming majority of times, it won't be someone who's African-American. I get that, makes sense. But if we're going to think, if we're, scientists and engineers and we want to approach these things, in a more rigorous way, we have to think about the fact that by the time you get to the second hire, if you're saying these two things are statistically independent, you're now saying that if you didn't pick up one, it's really 97% of 97%, right? You've got to multiply the probabilities if they're statistically independent, okay? So let's carry that out a little bit further. By the time you get to 100 hires, even in a population where only 3% are African-American, there's only about a 5% chance that you wouldn't have found one just randomly. By the time you get to 200, about a 0.2% chance. By the time you get to, by the time you get to 300, I think it's down to around, let's see. It was 0.01 there, sorry about that. So what I would say then is that the odds against ending up at zero by random chance, the odds against that are astronomical. So we might as well take some inspiration from astronomy. Enrico Fermi, Nobel laureate in physics back in 1950, was talking with some colleagues and blurted out, where is everybody? In the search for extraterrestrial intelligence, if we assume that life is probable because it came up, pretty fast after the Earth was formed and reached the conditions where life, could happen. And, there are lots of other planets out there orbiting lots of other stars. Shouldn't we be able to see signs of life in other parts of the galaxy or the universe? But we don't yet. So where is everybody? And so to try and get at the answer to that, Frank Drake, who many of you probably saw in the news, just passed away this past week. I was fortunate enough to have the chance to see him speak. I saw him speak about 15 years, actually almost 20 years ago. I had a summer faculty fellowship at NASA, and at NASA Ames in Mountain View, California. And we got to go down to San Jose to the SETI Institute and saw him give a talk. And his basic idea, he formulated this in 1960, was we ought to be able to estimate the number of civilizations that we should be able to detect in our galaxy. And so the basic idea is we're trying to estimate that number in. And I will say that when I first saw this, it was a little bit confusing for me because I wasn't sure why there was a rate term in this. But thinking through it enough, I eventually figured out that the basic idea is that you're kind of imagining a pipeline where civilizations are coming into existence and sadly, possibly going extinct. So there's some length of time for which the civilizations are detectable. And if you think through it for a while, you can reason out that, the number in the pipeline should be determined by, once you've reached a steady state, should be determined by the rate of star formation, times the length of time for which these civilizations release a detectable signal. You multiply that then by various other factors like the number of planets around each star. But then you have these other terms that you multiply by, such as the fraction of stars with planet, the fraction of planets that develop life, the fraction of planets that develop intelligent life, the fraction of civilizations that release a detectable signal. Okay, so a lot of science over the past 60 years or so has been driven by trying to come up with better and better estimates for these numbers. I would say that if you're searching for African-American terrestrial intelligence, then you're in a similar search and we can develop a similar equation. This fortunately came to me, I think it was actually the morning of my job talk. I had been thinking through that random approach to it for a while, and speaking with a friend who is an astrophysicist. He's now retired from UC Berkeley, Gibor Basri. He went on to become the vice chancellor for equity and inclusion. So he thinks about these issues a lot too. And when I was talking about the random analysis, he says, is that the right way to do it? I mean, the problem is we don't hire randomly, right? So it occurred to me that there ought to be some way to apply a Drake equation to this. And so this is what I came up with. Instead of the rate of star formation, we have the rate of African-American PhD graduates. And instead of the length of a detectable signal being released, we have the length of an average career, right? And so I group a few of these terms and then we'll also throw in the fraction of graduates in STEM fields. And I'm going to call those terms the pipeline, right? And the other terms I would refer to as the filters, right? These are the things we're doing that deterministically, right? So we basically have argued that you can't get to zero by random chance, okay? And if it's not random, it's deterministic. I think those are the only two options. That might be the good news. If it's deterministic, then we ought to be able to control it and affect it and make change, right? Let me step back for a second too and say that analysis that I gave applies to any room, anywhere, okay? I live in the state of California. As of about 20 years ago, whites were no longer a majority in California. As of around 5 to 10 years ago, I think about 5 years ago, no group is a majority. I'm sorry, whites are no longer the largest share even. Hispanics actually are the largest percentage in California. So if you walk into a room in California and there's enough people there to, get good statistics, and any group is in the majority, that room is out of skew with the population of this state. And the larger that room is, the less likely it could get out of skew by random chance. There are deterministic forces that are causing this, okay? So the fraction of African-American STEM graduates who apply for your positions, the fraction of applicants who match specific technical / project / programmatic needs, the fraction of applicants who meet some measure of merit. So, in my job talk, this was, I think, the final slide. Actually, I only had 4 slides on diversity. And I said, I'm not going to carry this analysis far enough to plug in numbers for you. But I will tell you that my working hypothesis is that if you do plug in numbers, you're going to have a hard time justifying 0. Okay. But once we have an equation, it gives us a way to frame the discussion, because now we can talk about some of these filters and what are the things that we can do about them. Okay. Solutions. Let me also just check in. So I think we were planning for me to start at 10:10, which would mean I'd finish at 10:40. I think I started it more about 10:15. When would you guys like for this to wrap up?
So you have still a time, like another 5-6 minutes more.
Okay, good. So what can we do about some of these filters? The fraction of African-American STEM graduates who apply for positions. Well, we do a lot of hiring through our networks, right? And so expand beyond our networks or diversify our networks. I'll talk about a program that does that. Go where the underrepresented populations are overrepresented. I was so excited earlier this month to attend an AI for Science workshop that was held by DOE, where about 200 researchers came together to talk about, I guess, plan for where we'd like to see AI for Science going, and to be able to come out with a report that advises DOE on that. And we held that workshop at a historically Black university, Bowie State. And we involved that university. They actually calculated that something like 11% of the participants in the workshop were from the university that hosted it, okay? We need to go where the underrepresented groups are overrepresented. The fraction of applicants who match specific technical needs. So a lot of hiring, in my observation at government labs, I've been at 3, the Naval Research Lab, Sandia, now Berkeley Lab, a lot of the hiring is driven by project needs. That makes it very narrow in terms of who we can hire. And somebody just highlighted something on my slide here. I don't know if that was on purpose or not. So what we did at Sandia was we put together an early career LDRD program. LDRD is Laboratory Directed Research and Development. It gave managers a pool of money they could tap into for 2 years to just go out and find the best talent they can find, not depending on project money, so that the people they hired would be funded for 2 years. And these were not postdocs, these were career staff hires. And it was done with an eye towards diversity and inclusion. I hired someone when I was at Sandia on that funding, Carla Morris, who just made distinguished member of technical staff at Sandia. So she's had a distinguished career there. I was in the combustion research facility. She had written a dissertation on turbulence in superfluid liquid helium, a phenomenon that occurs only below 2.1 Kelvin. So the opposite end of the temperature spectrum from combustion. But she was stellar. This is a woman who, Black, Hispanic woman, and at one point when I first met her was undocumented and has gone on to a phenomenal career, but there's no chance that I could have hired her if it had to be tied to project money. The fraction of applicants who meet some measure of merit. When I was talking to the professor I mentioned on campus, and he said, yeah, I've thought about doing the kind of analysis you're proposing, but I was always worried that if I did it, maybe I could justify 0, right? Because we're looking for 3 sigma people. Well, that's easy to say, but 3 sigma is a precise statement. So if you're going to say something like that, the first question I'm going to ask you is, what's the random variable you're talking about? Second question I'll ask you is, do you have data that shows me that everyone you've hired for the last several years is 3 standard deviations above the mean in that random variable? The third thing I'm going to ask you is that if you can do that, do you have data that shows that random variable is predictive of future success in your organization? Because if you can't do all these things, I'm going to call BS. And that was actually the end of my job talk. Somehow they still hired me. I was talking with a friend who's the president of the National Society of Black Physicists, and he pointed out to me that what I was saying here was not new. Even at Berkeley Lab, there was a scientist, Keith Jackson, who wrote an article back in 2002 saying largely the same things. Like, we go out and have these K through 12 efforts where we bring kids in, to talk to them about, did we skip over? I skipped over a slide here. To talk to them about science. But if they don't see that there's any, if you bring in a bunch of Black kids and they don't see that there are any people of color here, then they might conclude that this isn't really an option for them. But most importantly, what he was saying, I'll just say quickly, was this is not a pipeline issue. There are people in the pipeline that we're not hiring. And what was he saying about what we can do about that? Things like summer programs. This is getting back to diversifying our networks. So a summer program that I'll mention, hopefully many of you have heard of it by now. It was pioneered at Berkeley Lab. It's called Sustainable Research Pathways. They've now taken the show on the road, and there are 8 labs involved in the newest version of it, which is SRP for HPC. And what this does, I call it speed dating for research. Lab staff present the work of their group. Faculty and students from a very diverse array of colleges and universities present their work, and we try to match. And through SRP HPC, since it was funded by the Xscale Computing Project, ECP, if a match happens, ECP funds them to come in for a collaboration over the course of the summer, and you don't have to tap into your project funds. I had 3 people work with me this summer through the SRP HPC program. 2 were Hispanic, one a professor and his undergraduate student from Northern New Mexico College. I had never heard of Northern New Mexico College until I met them. A third was an African-American student from San Diego State University. So the goal here with SRP HPC, led by Marianne Leung, who leads the Sustainable Horizons Institute nonprofit, is to diversify our networks and hopefully, therefore, thereby diversify our hiring. So I think I have about 3 minutes to go here. Last few things I'll say. This is also getting towards a solution, but I need some time to set it up. So I'll set it up by saying a diverse workforce does work differently. This is a great book that my partner and my son gave me for Father's Day a few years back. It's The Jazz of Physics by Stephen Alexander at Brown University. He's an African-American physicist. When I first saw the title, it seemed a little bit backwards to me. I'm used to seeing books like The Physics of Jazz, and they'll talk about a vibrating string and acoustic waves and what have you. No, this is about the jazz of physics. It's about the fact that he's also a jazz musician, and he goes to jam sessions, and the music he hears inspires his physics theories. That might sound kind of hokey until you read the book, and he's got quotes in there from 2 Nobel laureates. Abdus Salam was one who at one point turned to a Black PhD student at the time, Jim Gates, and said, one day when your people do physics, it will be like jazz. Albert Einstein, another quote in the book, said, it occurred to me by intuition, and when he was asked about his theory of relativity, he said, it occurred to me by intuition, and the driving force behind that intuition was music perception. So 2 of the top physicists of all time are telling you that there is an analogy between the way they see physics theories being developed and music. Now connect that with the fact that Stephen Alexander is performing music from an African-American tradition. That therefore tells you that even physics will be done differently when we have a more diverse group of people doing it, right? I would also say that a diverse workforce does different work. This is from an article that a paper that I published at the Collegeville Workshop 2020, and it also then became a blog post on the Better Scientific Software website, where I talked about the fact that as an African-American, I see my adopting an underdog language, Fortran, as partly being an extension of being outside the dominant culture in STEM fields. At a time 20 years ago, when most people who were passionate about improving scientific software development were adopting other languages, I found that an ability to embrace difference and combat stigma along one obvious dimension, I'll say race, makes it feel natural to swim upstream or outside the mainstream along another dimension, programming language choice. So guess what? You finally get a Black staff scientist here. That might mean you're going to be doing Fortran for the first time. There was nobody else around here doing Fortran, okay? We will be doing different things technically when we hire a different population of people. And those two things, I hypothesize at least, are related. Really important to recognize that, and I'll wrap up, got, I think, maybe 2 or 3 more slides here I'll run through quickly. I won't have time to talk about this one in detail, but I presented it, or I didn't get to present, but I had an accepted position paper at a workshop in December that talked about programming language bias. It's really important to recognize that programming languages are human languages. You write source code for other humans to read. Sometimes that other human is your future self. You're not writing it for the computer. If you're writing for the computer, you could just write 1s and 0s and be good to go, okay? Just like there are biases that come into play in spoken languages, there are biases that come into play in programming languages. And we need to address those if we want to have more diversity in our workforce. You can see it come out when you see in the published literature, people saying things like, Fortran, the infantile disorder, by now 20 years old. This was written back in the 1970s, and I found it in a course syllabus from 2001. You know, how would you feel if someone described your life's work? I mean, I'm most known for my work in Fortran. I gave the keynote address at the International Fortran Conference last year. How would you like it if someone described your life's work as an infantile disorder? How does that feel? You can write Fortran in any language. That's a common thing that software engineers say. It's their way of saying you can write bad code in any language. Fortunately, I think we're turning a corner in some ways. I found this one article where someone said real programmers write Java like Fortran. So maybe they're acknowledging that, you know, this was actually saying it's a good thing, I guess. I just want to point out there's data here. I'll put these slides online. Fortran is not going anywhere. It's not gone. It is still very much a language. This is actually not even human surveys. This is looking at runtime data. What are the runtime libraries on the top platforms at the NERSC Supercomputer Center? This is from 2014 through 2018. And they can detect that Fortran is neck and neck in the latest data from Corey 2018, neck and neck with C++. Somebody tell me that Fortran is dead. Rumors of Fortran's demise are greatly exaggerated. I think this is my last slide before the conclusions. Just want to mention this concept of intersectionality. It was first popularized by Kimberly Crenshaw, who's a UCLA School of Law professor. This article where she, you know, I don't think she was the first person to invent this concept, but this was the article that I think that really made the splash. When I checked a year ago, the article had 21,000 Google Scholar citations. When I checked last night, it had 27,000. This is an article from the 1970s. It's had 6,000 citations in the past year. Talk about impact. What she was doing was looking at what happens at the intersection of two groups that experience discrimination. And it's really interesting. What happens there is not just double discrimination, it's actually things that are unique to that intersection. Okay, so I think a lot about this because I'm a Black guy writing Fortran. And what she was getting at is, she was looking at a case where a company was being sued for discrimination by a Black woman. Unfortunately, the court threw the case out because Black woman is not a protected class. Black is a protected class, but the problem is the company was hiring Black people. It's just they were mostly hiring males into jobs that were manual labor. Woman is a protected class, but the problem is the company was hiring women, but they were mostly white women in front office jobs like receptionists. So if you were a Black woman, you're out of luck, sorry. Things happen at the intersection that don't happen elsewhere. My recommendation is resist the juggernaut, okay? We see things like one parallel programming model that's used in over 90% of parallel programs. That's a juggernaut. That's a problem when we have other parallel programming models like CoLRay Fortran, where I don't have time to go into the details, but I can show you outperforming NPI. Even when the CoLRay Fortran is supported under the hood by NPI, it's still better NPI than you would have written yourself. Or GasNet EX, a competitor to NPI. We can show you better performance. Why is it that 90% of codes are still using NPI? So Black lives count, but only if we can count Black lives. We've got to disaggregate the data. The odds against a significant difference from the pipeline happening randomly are astronomical, folks. We don't get to this situation randomly. It's deterministic. The good news, if it's deterministic, we can solve it, we can change it. And there are solutions out there. I talked about the SRPHPC program. A diverse workforce does work differently and does different work. Programming languages are human languages. Bias can be intersectional. Inclusivity requires a diversity of thought. We've got to combat stigma. I can't tell you how often I'm at a workshop or conference. Just at this AI workshop I went to a couple of weeks ago, I'm glad we were at an HBCU, but someone stood up at the meeting and said, okay, so we're all doing modern programming these days. We're writing C++ and Python. Guys, half the cycles on the top platforms are still Fortran. The definition of writing modern code isn't we're writing C++ and Python. There's modern Fortran too. We've got to combat stigma. We have to resist juggernauts. Okay, hope I haven't used up all the time. I can take questions if there's any time.
Thank you so much, Damian. So this was a fantastic talk. And I let you talk longer because we had the comments that everyone was like, no, don't interrupt him. Let's get it on. Okay. So I didn't interrupt you anymore after I gave you only 5-6 minutes. So,
thank you. Sorry about that.
I told you I would interrupt you. I didn't do it. So, but it's open for questions. I only wanted to say, so the official break was planned from now for 15 minutes. Let's go into the break a little bit. I think we can afford to start maybe then a little bit later or have only a 5-minute break. So please, everyone who has a question, put it in the chat room or raise your hand. Speak up, whatever you prefer. And we got one comment in the chat. Devastatingly important talk. Thank you, Damian from Peace Baby. So, any questions? So I have a question. Oh, sorry, David.
Hi. Thanks. Great talk. 2 questions, which might be completely unrelated. Totally hear everything you're saying about, being able to count. And then at the end, you talked about intersectionality. And we know that, race is real, but it's a concept that's been used to control and repress people. And the way we measure race has changed. The way we even take surveys and the way that we make these categories has changed. So can you say a little bit, is there a way that we can make sure that we are counting people and make sure that we're not just reinforcing these existing categories? And do we need to have more dimensions? And then just unrelated, but since you brought it up, that I recently found out that there's a book, I was trying to look it up really quick, about how to write good APIs for scientific research. And it's all based on Fortran. I'll look it up and I'll put it in chat. And I wondered if you could say a little bit, since you're talking about let's not just embrace the juggernaut. Do you think that there's like lessons learned about a good way to write in Fortran? Do you see like commonalities? Should we, are we all sort of like reinventing the wheel in sort of like trying to write, like domain specific code? I don't know if that question's clear, but
Sure, yeah.
Yeah.
Yeah, so the first part of your question, I too worry that we could just put this data out there and then it's like, oh man, that's depressing, but not necessarily go deeper. So I think what we really need to do is we have to bring the same level of rigor and data to this discussion that we do to the rest of our work, right? So we've got to go deeper. It's not just about showing that there aren't enough African Americans here. We need to do further analysis. So I'm very fortunate to have an ally, Deb Agarwal, who's a division director here at the lab, who, because I've been pushing so hard for this, went out and got more data. And so she just presented this for the first time a couple of weeks ago at a meeting of an all hands meeting for 2 divisions here at the lab. And the data that she gathered showed that if you look at the distribution in these same groupings, underrepresented minorities, other people of color, whites, in terms of our qualified applicants. So this is just the pool of people that managers have designated as being minimally qualified for the position. And these are the people that we will at least consider, do a phone screening, interview, what have you. It turns out that when you get from that to who we hire, both the underrepresented minorities and the other people of color, which is Asians, Asian Americans, Pacific Islanders, both take a hit. There's a drop in 20% for African Americans from the qualified applicants to the hired. There's a drop of like roughly 33% for Asian Americans, Asians and Pacific Islanders from the qualified applicants to who we actually hire. It's really interesting when you see this kind of data, because in the public dialogue, we're hearing about like, there's a lawsuit, I think, pending before the Supreme Court right now about schools like Harvard discriminating against Asian and Asian American people. And these lawsuits are typically blaming affirmative action, which benefits the underrepresented groups. But our data shows that what's happening here is both groups are taking a hit. And the one group that's benefiting is white applicants, going from like 41% in the qualified applicant pool to 57% in the hired pool. So we've got to go deeper. We've got to, do a lot more analysis, not just stop with this group's woefully underrepresented. Then your question about Fortran. So I mentioned I gave the keynote last year at the International Fortran Conference. And I talk a lot in that about programming patterns that I recommend. I've developed a way of doing functional programming in modern Fortran. And I talk about several different programming paradigms and how one supports another, sometimes two combined to support a third. So you might check out that talk. I haven't unfortunately had a chance to publish that in a paper just yet. Sadly, this was a talk that I gave remotely because the whole conference was virtual a year ago, and my laptop battery died in the middle of the talk. So it took me about 6 minutes to recover. I switched laptops. I downloaded the PDF of my slides from the conference website and I got going again. But so there's a 6-minute gap in the middle of the video, but otherwise I'd recommend checking that one out for my take on how to write modern Fortran using Fortran 2018.
Cool, thank you.
Great, thanks. So I think we had a couple of more comments, and of course, thank yous to you, Damian.
Sure.
I don't see a direct question. So, but I would have a question. So when you talk about, bringing out the numbers also more there, and that it's not only the pipeline. So the numbers, let's say, for example, I work for the University of Illinois, and Chicago is also a minority serving institutions. So they reflect that they have a high partial, in students, but it doesn't continue then with PhD students in that same ratio. What do you think? What is the reason then for that? That even if the pipeline seems to be okay with the undergraduate students,
Sure.
that it doesn't continue then for
Yeah,
the institutions?
it's a leaky pipeline. I mean, you know, given that I'm not a social scientist, I can't say a lot about this broadly. I can say my experience, and I can also maybe, you know, quote a social scientist. One person I'd recommend whose work I recommend reading is Claude Steele. He's probably emeritus by now, but professor of psychology at Stanford, and he also was at Berkeley for a while. He's done a lot of great work on underperformance of various groups. Now, when he says underperformance, what he's saying is, for example, you might look at a cohort of high school students with certain incoming indicators, SAT score, high school GPA. Based on that, you know, you should be able to predict with some level of accuracy what their graduation rate would be, what their graduating GPA would be in college. And what's happening is there's a phenomenon where, you know, students from underrepresented groups are underperforming their peers who come in with the same statistical indicators, right? So there's so much discussion in the public debate on these topics around affirmative action and around lowering our standards to, you know, get certain groups in. What you see when you look at the data is it's not so much about lowering our standards, it's even when we bring people in with the same statistics, we're doing something to screw them up once they get here. The problem isn't them, it's us.
Yeah, I'm totally with you there. Yeah.
One of the things he talks about is connectedness. So I'll just say that it matters a lot. I had a really, really amazing PhD advisor. I would not have made it through my PhD program without him. Connectedness matters a lot. Feeling that you're part of whatever department or research group you're in.